Hello. So we're gonna go and start chapter 2, which is functions and graphs. And this is our first lesson, 2.1 basic functions and their graphs. So again, just like with any other video, if you need to, please pause it and then continue when you're ready to continue. Or if you have any questions, don't hesitate to ask. Okay, so first thing what we're going to do is we're going to define what a relation is. So a relation is any set of ordered pairs. So we can do, for example, 2, 3 is an ordered pair, 126 and 354 is an ordered pair. So the first of the ordered pair, um, the first coordinate is, or the first number is the x coordinate, and the second number is the y coordinate. So x and y. Okay, so the set of all first components of the ordered pairs is called the domain of the relation. So that's our x values and or x coordinates. And the set of all second components is called the range of the relation. So for example, the 3 and the 354. So it's the y coordinate that is the range. Okay, so in this example, we're going to find the domain and the range of the relation. So we're going to go ahead and see the first component, so the x coordinates, 0, 1, 2, and 3. And domain is a set, so we're going to use braces for it. So 0, 1, 2, and 3, we're just listing it inside the braces. The range for this is, those are the y coordinates, so the second component, so 187, 212, 225, and 238. And we close the braces. All right, next, what we're going to do is we are going to look at, so, okay, we're going to look at the definition of a function. So we looked at relation, but now we're going to look at a function. So a function is a correspondence from a first set called the domain to a second set called the range, such that each element in the domain corresponds to exactly one element in the, and I meant to use the colors up, in the range. So each element in the domain corresponds to exactly one element in the range. So we're going to look at this example here that we've got. Determine whether the relation is a function. So let's list the domain. We've got 1, 3, 6, and 8. And then for the range, we have 2, 4, 5, and 5. So if we look at those now, every element in the domain, so 1, 3, 6, and 8 corresponds to exactly one element in the range. So there are no two ordered pairs in the given relation that have the same first component and different second component. So we could, draw lines here and each one is different. So this is a function. It's a relation anyways, but it also is a function. Okay, next thing we're going to look at are functions as equations. So if an equation is solved for y and more than, one value of y can be obtained for a given x, then the equation does not define y as a function of x. So let's look at this next example here. We have x squared plus y squared equals 1. So we need to solve it for y first. So we're going to subtract x squared to move those to the other side. So y squared equals 1 minus x squared. Now we have a squared, so we're going to take a square root, and remember that when we take a square root, we need to add the positive and negative. So y equals positive and negative 1 minus x squared and a square root of that. So because we have the positive and negative, it shows that for certain values of x, there are two values of y. So even though, we would have one value of x, if with the positive and negative, we're gonna have two different values for y. So this does not define as a function, not a function. It's still a relation, but it's just not a function. Okay, next thing we're going to look at is function notation. So the special notation like this is read f of x or f at x. It represents the value of the function at the number x. So the next example, if we have f of x is x squared minus 2x plus 7, and we're going to evaluate f of negative 5. So we're plugging in the negative 5 where the x is. So negative 5 squared, and make sure you put it inside parentheses because the negative is part of the base. Minus 2 times negative 5 plus 7. And now we're going to solve. Negative 5 squared is 25. Negative 2 times negative 5 is a plus 10, and negative is a plus. And then plus 7, and now we get 42. So f of negative 5 equals 42. You can always plug that in the calculator from here. That is totally fine. Just again, make sure that you've got the parentheses in the correct spots. Okay, next we're going to look at graphs of functions. So the graph of function is the graph of its ordered pairs. And for this, make sure that you're able to, or you know how to use on MyMathLab the graphing tools and all that. It is in the orientation so that you're able to do these problems. Okay, we're going to graph the functions f of x equals 2x and g of x equals 2x minus 3 in the same rectangular coordinate system. How is the graph of g related to the graph of f? So what we need is we need to select integers for x. So starting at somewhere here. Um, so what we're gonna do is we're gonna set up tables or a partial table. So we're gonna do x here and then y equals 2 times x. We're gonna start with -2. So 2 times -2 is going to be -4. So our ordered pair is -2, -4 right here. We're going to continue with -1. So 2 times -1 is going to be -2. So -1 and -2 is right here. 0, 2 times 0 is 0. So that's our point. 1 is going to be 2 times 1 is 2. So 1 and 2. 2 is our last one. 2 times 2 is 4. So 2 and 4. So you need at least 3 points to make sure that there's not a mistake. It should be a straight line here. But if, I mean, 5 points makes it a little bit easier. Let me see if I can use the ruler to, oh, nope. Come on. Draw a straight line here. Here we go, something like that. And it keeps going and going. Okay, so this is the f of x equals 2x. Now we're going to do the same thing with the g of x. So we're going to plot the same points, or plot the same x's, I should say. So -2, -1, 0, 1, and 2. And our y is now 2x minus 3. So 2 times -2 minus 3. So -4 minus 3 is -7. So our first point is -2 and -7 right here. 2 times -1 minus 3, so that's going to be -5 right here. 0, 2 times 0 minus 3 is -3. 1, 2 times 1 minus 3 is -1. 2 times 2 minus 3 is 1. So 2 and 1 right here. Okay, let's draw that line. Here we go. So this one is the g of x equals 2x minus 3. Now, how is the graph of g related to the graph of f is a question. If we look at the graph g, we can see that the graph of g, so they're both parallel, right? It's they're never going to touch each other. So the graph of g is the graph of f, but it is shifted down 3 units. So that's the -3 right here. That shifts it down. You know what? This is missing one part here, which is actually weird. It's missing the vertical line test as I'm looking at this. So we're going to hop on vertical line test. undo that part. That part right here. Then we'll come back to what we had here. And now again, why is it not giving me an extra page? This is weird. Because then when I go at the end, it'll give me an extra page. Okay, we can do it here. So the vertical line test for functions. What it means is that if any vertical line intersects a graph in more than one point, the graph does not define y as a function of x. So what does that mean? We're going to go ahead and do a couple of examples. So I'm going to graph an example like this. Now, if I do a vertical line test, so that means that I'm going to draw vertical lines here. It only intersects the graph in one spot. So we know, there we go, there's that extra page after I write on this. Okay, anyways, since it only crosses it, each vertical line crosses in one spot, this is a function. Now, if I draw, well, it doesn't actually matter, but at somewhat of a circle, that's not an exact circle. If I do a vertical line test here, you can see that this one vertical line crosses in two spots, the graph. So this is not a function. Okay, let's go back to where we were over here. So we're gonna use the graph to find f of 5. So what we're gonna do, f of 5 means that, again, this is x, f of x. So we're gonna look at the x axis, find 5, and then start going up to where it meets the graph, right here. And then we're going to go to the left, and we see that f of 5 is 400. For next, for what value of x is f of x equals 100? So we're going to look at where the 100 would be. This is 200, so 100 is somewhere right here. I'm going to keep going until I hit the graph, which is right here, go down, and I can see that it's 9. So f of 9 equals 100, so that means that x is 9. Okay, next we're going to go ahead and identify the domain and range from a functions graph. Now I need to remind myself of what colors I used for the domain and range. Domain is green. Okay. So to find the domain of a function from its graph, look for all the inputs on the x-axis that correspond to points on the graph. So that is your domain. To find the range of a function from its graph, look for all the outputs on the y-axis that correspond to points on the graph. Okay, we're going to use the graph of the function to identify its domain and its range. So we're going to start with that left one here. So our domain, again, we're looking at the x. So we're starting with the -2, and we can see that it ends at 1. So this is our domain. And now there's two different ways to write the domain. We can do braces x and a straight line. That means x is such that -2 is less than or equal to x is less than or equal to 1. And we close the braces. So this means that we are between -2 and 1. These are both closed dots, so shaded in dots. So they are included. So this line, the equal line, means that they are included. The -2 and 1 is included. Another way to write the domain would be -2 to 1 and inside brackets. Bracket means closed, that it is included. So both the line here and the bracket means that included. Okay, let's look at the range for this one. So the same thing, because they are dots, like shaded in, so they are both included. We're going to do the same thing. A range is going to be y is such that. So we're looking at the y. We're starting, the y starts from here. Actually, I shouldn't draw a circle there. The y, did not mean to erase the whole thing. So the y starts from here and it goes all the way to here. Actually, it doesn't go that far down. Now I'm erasing everything. There we go. So we are starting, y starts from 0, and it is less than or equal to, and it goes all the way to 3. Actually, I need a y here. 0 is less than or equal to y is less than or equal to 3, and we close the braces. Or it's 0 to 3 inside brackets. Now, if you look at this next graph here, there's a difference. So this is a circle. So that means that this is not included. So we're either going to use parentheses or we're going to use only the less than or greater than sign, not the line under it as well. Okay, so let's look at the domain for this one. We are starting at -2 and going to 1. So x is such that -2 is less than, x is less than or equal to 1 because the 1 is included in there. And we close the braces. And if we want to write it the other way, -2 is going to be, this is going to be parentheses because -2 is not included, and 1 is going to be inside a bracket because the 1 is included. For the range, again, y is such that, and y is going to be 2 to -1 right here. So we start with -1 is less than or equal to, because the -1 is included, y is less than 2, no equal. And then we're going to do -1 in brackets, 2 parentheses. So when we're writing this, we're writing it from the smaller to the larger, even though like this one's going, you know, from left to right, it's going downhill, but we're still, it's always the smaller number first. All right, next thing, we're going to go ahead and identify intercepts from a functions graph. So to find the x-intercepts, look for the points at which the graph crosses the x-axis. To find y-intercept, look for the point at which the graph crosses the y-axis. And a function can have more than one x-intercept, but at most one y-intercept. It's not a function if it has more than one y-intercept. It fails the vertical line test because y-axis is a vertical line test, or a vertical line, sorry. Okay, so let's look at identifying the x and y intercepts for the graph of f of x here. So our x-intercepts are right here, -3. Next one is -1, and next one is 2. The y-intercepts are, or is, -6. Y-intercept is -6. Okay, so that's it for this lesson. Again, let me know if you've got any questions. Bye.